Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to give you a code review. And what I wanted to do is I wanted to make a really short regression and prediction and visualization using Seaborn's Diamond dataset. And that's what I have done. And so I've done this in only 17 lines of code. And to do it in 17 lines of code, I wanted to do a code review, how you can do this in 17 lines of code. I was able to do it because I was able to use semicolon. Because when you use the semicolon in Python, that just automatically takes you to the next command. So we're going to go ahead and go over the code review, and we're going to see how we have done a complete regression and prediction and visualization in only 17 lines of code. So the first line of code, what we did was we imported our libraries. So we import NumPy as NP, which is the numerical computation library. That's a semicolon. We import pandas as PD, which is the data frame manipulation and creation library, semicolon. Import matplotlib.pyplot as PLT, which is our graphics library, semicolon. We import Seaborn as SNS, which is the higher level graphics library written on top of matplotlib, and which is the one that we get our dataset from, semicolon. From sklearn.tree, import decision tree regressor, which is our regressor, semicolon. From sklearn, import preprocessing, semicolon. From sklearn.preprocessing, import ordinal encoder, which is what we're going to do to ordinal encode the categorical values in the columns. So that completes our libraries that we have imported in line number 1. In line number 2, we're going to import the library. We're going to import the dataset from Seaborn. So data equals sns.load_dataset brackets diamonds, comma, cache equals true, comma, data home equals none, brackets, semicolon, data. And so now you can see the data set that has been converted to a data frame. And it's 53940 rows by 10 columns. If we had done an info on it, you would see that 2 of the columns were categorical. And when we go to encode the columns, the ordinal encoder will not encode categorical columns. So what we had to do was we had to convert those columns to string values. So now we get to row number 3 to 5, and we have a for loop for call in data colon if data call dot dtype equals category, data call equals data call dot as type string. So all of the categorical columns, what we have done is we have converted them to object columns, and when we convert them to object columns, we will be able to encode them with the ordinal encoder. And then lines 6, 7, 8 is where we actually encode. So if for call in data, I'll just take that out. You can see I was experimenting with code. If data call dot dtypes equals object colon data call equals ordinal encoder brackets dot fit transform brackets data call dot values dot reshape -1 1 brackets. And so that's takes you up to line 8. Now line 9, 10, 11, what we're going to do is we're going to define our training and validation sets. So train equals data.sample brackets frac equals 0.9 comma random state equals 42. So what that does is that creates our training set. It gives the sample function gives a random sample, and the training set is going to be 90% of the data set. And then for our validation set, val equals data.drop brackets train.index. So for the validation set, we're going to drop all of the rows pertaining to train.index, and that's going to leave our validation set. That was row number 9. Row number 10, we set up our ytrain xtrain values. Ytrain equals train brackets price semicolon xtrain equals train dot price brackets train dot drop price axis equals 1. That was for line number 10. Line number 11 is yval equals val brackets price semicolon xval equals val dot drop price axis equals 1. So the line 10 and 11 are the same, except for on line number 10 we're using the train data frame, and line number 11 we're using the val data frame. So line 12, what we're going to do is we're going to define our model, and this particular occasion I decided to use the decision tree regressor because I have a lot of good luck with the decision trees. So model equals decision tree regressor brackets random state equals 42 dot fit x train y train, and so what that does is that defines your model. Then you get your semicolon. So print brackets model dot score brackets x train y train. So that gives you an accuracy of 99%. Wish it had been 100, but it wasn't. And then now in line 13, what we do is we make predictions on the model. Ypred equals model dot predict brackets x val brackets. So that's your actual prediction, and then semicolon, and print brackets model dot score x val comma y val, and so that's going to give you your accuracy score on the x val y val, and so that's giving you about a 97% accuracy. So that's that takes you up to line number 13. And line number 14, what we have to do is we have to get our error. And the reason why we have to get our error is because when you're working with a regression, your goodness of fit methodology is finding the error. So MSE equals NP dot square brackets NP dot subtract yval comma ypred dot mean brackets, And so that's going to give you your MSE, semicolon. RMSE equals NP dot square root MSC. So that's going to give you your RMSE, which is your root mean squared error. And then we're going to print the root mean squared error, and it's 742. So that's your goodness of fit, which is your root mean squared error. So that's line 14. So now we're going to go to line 15, 16, and 17. What that's going to do is that's going to actually plot the graph, because you need to have a visualization in every good model. So Fig AX equals PLT dot subplots, brackets, semicolon, AX dot scatter, brackets, Y val, comma, Y pred, edge colors, brackets, 0, 0, 0, brackets, AX dot plot, brackets, square brackets, Y dot min, comma, Y dot max, square brackets, comma, square brackets, Y dot min, comma, Y dot max, brackets, square brackets, comma, K dash dash, LW equals 4. Okay, so AX dot set X label, brackets measured, semicolon, AX dot set label, set Y label, brackets predicted, semicolon, PLT show, brackets. And that's it. So that's line 15, 16, and 17 of your code. So we have done a complete analysis on only 17 lines of code. And obviously, we just did this really quickly. One thing that we could have done, which would given you more lines, which would given you an extra line of code, which we could have done this. That will give you 18 lines of code. Let's try that. Let's try it once more. try that, see if it works. So we got it to work now. So it said that Y was not defined, and it wouldn't work because Y wasn't not defined. I don't know why it didn't pick it up at the very beginning. So we had actually really one extra line of code. So actually we had 18 lines of code because we added another line of code called SMS plot, so you can see the price. And you can see that. So yeah, instead of 17 lines of code, we now have 18 lines of code just to make it a little bit better. And we corrected the error in the plot graph code because it plotted the Y whenever I did it, but for some reason it doesn't want to plot the Y now. So that's been corrected. So now you've got the code if you want to try it yourself. And it's on Seaborn's dataset. So if you use Seaborn's dataset, you don't have to go looking for a dataset to use because I've included it in Seaborn. So I'm going to go ahead and conclude this video because I've covered everything that I want to cover. And I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you very much for watching my code review. And I'm going to be making more code reviews for you in the future.